Hello, everybody. So to get started, let's look at this graph here and let's see if we can try to figure out which of the following stories best fits the graph. So what I want you to do is I want you to pick between these four. Um, we have one story, which is a car is speeding up and getting faster over time. We have one, which is a car is slowing down and getting slow over time. We have one where a car is driving at a constant velocity over time, and then we have one where the car is not moving at all. So pick which one of you think is the one that fits this particular graph. Which story do you feel like fits this graph? For those of you who are just joining us, what I want you to do is I want you to take a look at the graph on the screen, and I want you to decide which of these following four stories best fits the graph. The first one story is that a car is speeding up and getting faster over time. The second one is a car is slowing down and getting slow over time. The third one is a car is driving at a constant velocity over time. And the fourth one is the car is not moving at all. So pick which one you feel like fits the best, and then we will look at this in a few minutes. We currently have 12 people right now, so let's get let's get 12 responses, please. So let's see, if you haven't answered the poll, please do so. So we currently have 16 people. We have about 8 responses, so we're about halfway. For those of you just joining us, please look at the graph on the screen and pick which of the following stories you think best fits the graph, and then pick the answer you feel like is correct in the poll. We're currently at about halfway, 9 out of 17. We are shooting for 100% as usual, so we need still about 8 more responses. We're at 12 out of 18 so far. We're about 2/3 of the way through. For those of you just joining us, please look at the graph on the screen and pick the answer you feel like fits the answer the best. Yo, what up? What's up, fam? How's it hanging? So for those of you just joining us, please look at the graph on the screen and pick which answer you feel like fits the graph the best. We currently have about 20 people. We have 13 responses, so we are missing 14 responses. So we are missing, I believe, 6 more. Five more, 14 out of 19, sorry. So we're missing out 5 more. So if you're one of the 4 who haven't responded to the poll yet, please do so. We actually have a pretty strong consensus, which is really interesting because we actually haven't looked at these particular graphs yet, but I think it's really interesting. Did I do something wrong? I don't think so. Okay, let's take another minute or so. I believe we're missing about 3 more answers. So if you haven't responded yet, please do so. Pick which answer you feel like fits the graph the best. We have a very strong consensus here, which I think is really interesting. Especially since I don't think we've actually looked at a graph like this yet. Okay, so what we are going to do is we are going to look at the numbers. We're actually going to look at this graph here and we are going to try to figure out what is the car actually doing. So before we can actually look at what the car is doing, let's first review a few things about graphs. So this graph right here is a position versus time graph. By this, I mean we have the position of the object on the y-axis, and then we have the time on the x-axis. So the slope of this graph here is our velocity, right? So the slope of a graph tells us how much the graph is changing. It tells us the rise over the run. It tells us how much the graph is changing. And the rate of change of your position over time is your velocity. So this, right, our velocity here tells us the slope of the graph, and it tells us how quickly our position is changing over time. Another thing we want to review is that when our velocity of an object is changing, it means that our object is undergoing some sort of acceleration. So if the object has no acceleration, it means that the velocity is not going to be changing. If the object has some sort of acceleration, then the velocity will be changing. So if we sort of connect the first two dots, what happens is that when the slope of a position versus time graph is changing, what this means is that the object has some sort of acceleration, right? The slope of a position versus time graph is our velocity. And so if the slope is changing, this means our velocity is changing, which means the object has some sort of acceleration. So when we're looking at a position versus time graph here, when we're looking at a graph like this and we're looking at the slope, we want to be looking at, is the slope changing? And whether or not the slope is changing will tell us whether or not the object has some sort of acceleration. So let's take a look at the graph on the right here. If we see is that the slope of the graph is increasing over time, right? So if we look at the slope here, right, it's initially like pretty small, then the slope here gets bigger, then it gets bigger, and so the slope is getting bigger and bigger and bigger, right? Because the graph is curving upwards. So every second you're covering more and more position over time. So because the slope of the graph is getting bigger, right, this means that the velocity is also getting bigger over time. And so this means the object has a positive acceleration. It has a positive acceleration because the velocity is increasing. Right, so the key takeaway here is that right, the slope of a position versus time graph is the velocity. And when the velocity of an object is changing, it has some sort of acceleration. So which means that if the slope of a graph of a position versus time graph is changing, it means that the velocity is changing, which means that there has some sort of acceleration. And in this example here, the slope is increasing, which means that the object velocity is increasing, which means that the object has a positive acceleration. Now, I think that part is, pretty, doable, right? It makes sense. What is hard though is figuring out whether or not that means that the object is speeding up. As we talked about, as we might have looked at recently, there's a lot of really wonky examples here where you might have like you might have your velocity increasing, but that actually means your car is slowing down or whatever. So there's actually a bunch of really weird cases where what we think might not match up with what's actually happening. So what we want to do is we want to figure out how do we know if an object is speeding up, right? What is the criteria that we know when an object is speeding up? Now, before we talk about whether or not how we know an object is speeding up, I think it's actually better to first talk about how do we know if an object is slowing down. So first off, we know that an object is completely stopped when its velocity is 0, right? If its velocity is 0, it literally means that it is not moving. Now, a negative velocity, all what a negative velocity means is you're traveling some speed in a negative direction, but the only time your object is stopped is when its velocity is 0. That is the only time your object is stopped, right? If it's positive or negative, it does not mean it's stopped. It just means that, it has a velocity. So what this means is that the closer the velocity of an object is to 0, the slower it's moving. This includes if it's negative. So if an object has, let's say, a negative 100 meters per second velocity, that means the object is going really fast. It just means that it's moving in the negative direction, right? An object that has a velocity of negative 0.5 is basically barely moving. It's just going in the negative direction. So basically, you got to think about it as the closer our velocity is to 0, positive or negative, the slower it's going, and the farther away it's from 0, it's the faster it's moving. So if I were to give you an example here, right, something like either a positive 0.5 or negative 0.5 meters per second, right? These are slow. right? The car is barely moving. It's barely moving in either the positive or the negative direction. However, if a car is moving, let's say positive 100 meters per second or negative 100 meters per second, this means that the car is going pretty fast. Now, the negative 100 just means that the car is going 100 meters per second in the negative direction. Of course, the positive 100 means that it's moving in the positive direction. So the sign of the velocity tells us which direction we're going. If we're looking at whether or not it's how fast it's going, we want to be thinking about this number right here, right? Is this number big or is this number small? So the smaller this number is, right, 0.5, or the closer the velocity is to 0, which means the slower it's moving. And the farther away the velocity is from 0, the faster it's moving. So in this graph here, the car has a positive velocity, and the reason why it has a positive velocity is the slope is positive, the position is increasing. So the velocity is positive, and then the slope is increasing, so which means that the acceleration is positive. So if you have the velocity that is positive and your slope is increasing, that means every second your velocity is becoming bigger and bigger and bigger. And because your velocity was initially positive, that means your velocity is going away from 0, meaning that your car is speeding up. So let's say in the beginning here, right? Let's say in the beginning here, your velocity was, I don't know, like 5. Here it might be 10 because it's increasing. And then here it might be 15. So notice here how every second our velocity is getting further and further away from 0, right? If we think about our y value here, it's getting the distance it has, the distance of the y value to the x-axis is getting further. So the farther away we're going from the x-axis, the faster we're going, which means that the car is speeding up. So we really want to be thinking about, is the velocity of our object going away from 0? Not whether or not it's increasing or decreasing, because that is very misleading. I think it's better to think about, is the velocity getting away from 0 or is it going towards 0? Because if it's going towards 0, it means that it's slowing down. And if it's going away from 0, it means it's getting faster. All right, so what we are going to do now is we're going to look at another graph here. So what we're gonna do is we're looking at another graph here, and then what I'm gonna do is I am going to put you into your groups here and have you discuss whether or not the object in this graph is speeding up or slowing down. So just so you know, just so you don't like lose this graph because you might forget, I want you to just quickly draw or write it down somewhere just so you don't forget. And then what I want you to do is I want you in your groups to decide whether or not the object in this graph is speeding up or slowing down. Take a minute to just burn this graph into your head. Yeah, I would probably draw it on a piece of paper or something, and then I want you to decide whether or not it's speeding up or slowing down. I'll give you a few minutes to do so. When we come back, I just want you to be prepared to write and share a 1-sentence explanation of your analysis in the group chat. Just quickly explain why you think it's speeding up or slowing down. Okay, so I'm going to put you in your breakout groups now. Head into them as soon as you have this graph burned into your brain, and then we will get started, and then we will take a look at whether or not it's speeding up or slowing down. hopefully y'all had a chance to talk about whether or not the object is speeding up or slowing down. What I want you to do is I want you to, in the chat, type in a very quick explanation of why you think the object is speeding up or slowing down. Don't hit enter yet. We'll hit enter in about a minute and a half. So I'm going to give you a minute and a half to type in why you think, why your group discussed whether or not the object is speeding up or slowing down. And then in about a minute, we'll take a look at everyone's responses. Don't hit enter yet. Type it in. Your response is ready. And then in a minute or so, we'll look at everyone's responses. And then we'll try to decide whether or not the object is speeding up or slowing down. So the first example that we looked at was kind of easy. This one is kind of harder. And then the next two will be even harder to understand. So I'm very curious to see what other people have to say, what their analysis is. That's very interesting. Take another 45 seconds or so. Just quickly type in what your group discussed on why they think the object is speeding up or slowing down.
What?
All right, so in ready, go, hit enter. Whatever responses you wrote. Whatever you wrote, hit enter. We got a few responses here. We got a lot of people discussing. We only. Okay, let's see. We got position increases as time goes on. The line is flattening out, so it's slowing down. Slowing down because the slope is decreasing. The object moves quickly and then slows down, slowing down, slowing down. We thought it was increasing, but then stayed at a constant, slowing down. Okay, so let's take a look at this and let's see what happens. So first off, what is the position doing the whole time? The position of this graph is increasing the whole time, which means that the velocity is always positive. Right, because our position is always increasing. And the slope of our graph is our velocity. And so as long as our position is increasing, our velocity is always positive. Now, despite the fact that our velocity is positive, what we want to figure out is whether or not our velocity is increasing or whether or not it's decreasing. So just because a velocity is positive does not mean the object is speeding up, right? Because the velocity, that means if it's positive, it just means that it's going forward. It does not mean that it's getting faster going forward. It just tells us the direction we're going. In order to look at whether or not the object is speeding up or slowing down, we need to be looking at how is the velocity changing. So in this particular example here, our velocity, remember, our velocity is the slope of a graph. So we got to look at the slopes here and we got to decide, is the velocity increasing or is it decreasing? So in this example here, we have initially a very steep slope. So our velocity is pretty high here. Then if you draw another slope here, right, the velocity is the velocity decreased a little bit, so it's medium. And then by the end here, our velocity is pretty much flat. It's pretty much zero. So our velocity is going from initially very positive to less positive and eventually hits zero. So we're basically going from a positive velocity to a zero velocity. So our velocity is, even though it's positive, it's approaching zero. It's getting close to zero. In other words, the velocity it's becoming flat. I think that's actually a good way of thinking about it. Is the graph becoming flat or not? If the graph is becoming flat, I actually really like this. I really like this idea that a lot of people have brought up. Let's write this down here. So when when a position versus time graph becomes flat, that means our object is slowing down, right? Because our velocity is coming close to zero. That means our slope should be approaching 0. So I really like that. That's really good. That's a really good idea. Obviously, what that means is the inverse is true. If the slope is becoming less and less flat, and more curved, that means that it is more and more vertical. It means that the object is speeding up. So basically, in this example, the object is slowing down, for the reasons we just talked about. So the previous two examples are, this example and the one before are, I think, a little bit doable. I think this one's a little bit harder. The last one's a little bit easier. The next one we will look at is going to be pretty weird, pretty challenging. So let's take a look at the next one here. Next one here. Ah. All right. So let's look at this graph now. This graph is kind of interesting. Is the object speeding up or is the object slowing down? So once again, I'm going to put you in your groups again, and I'm going to let you guys decide whether or not you think the object is speeding up or whether or not you think the object is slowing down. So opening your groups again. All right, so let's take a look at this graph now, and then let's see. So what I want you to do is I want you to do the same thing as last time. I want you to quickly type in what your group thought about whether or not it's speeding up or slowing down. And then we'll take about a minute or so. So about 1:12:42, just quickly type it in, and then we'll take a look at what people say. This one's going to be a lot harder than the last two. This one's going to be really weird. So we're going to spend some time analyzing this one. Graphs are really weird. Okay, it's in. All right, hit enter in 5, 4, 3, 2, 1, go. What did your group say? What did your groups say? Are we speeding up or slowing down here? Interesting, interesting. Very interesting. If you haven't hit enter yet, do so. All right, and then I'll start looking at this graph. So the long awaited question, is it speeding up or is it slowing down? So first off, let's take a look at this graph here. Let's analyze the velocities. So in this graph here, our position is decreasing over time, which means that our velocity is negative the whole time. The question is, even though our velocity is negative, how do we know if we're speeding up or slowing down? So if the velocity is becoming more negative, what that means is that we are going faster and faster in the negative direction. So we actually don't want the graph to become, the slope to be more and more negative. We want the slope to be closer and closer to zero, right? Zero means you are stopped. So we want our slope to be getting closer and closer to zero. So in this graph here, we initially have a pretty steep slope, right? We're going pretty fast. Then around the middle here, we actually start slowing down a little bit because our velocity went from being pretty steep to being a little bit less steep. And towards the end here, our velocity is almost flat. It's getting there. So it's getting there. You know, it's not quite there, but it's getting there. So towards the end here, we're actually getting pretty close to zero. So initially we got really fast. Our velocity becomes less and less. It becomes more and more flat, and eventually at the very end, we are going to be stopped. So in this graph here, we are actually slowing down, which can be really weird. So I think one helpful thing I think a lot of people have been looking at is just the shape of the graph. Is the graph becoming more flat or is it becoming less flat? The more vertical the graph becomes, it means it's speeding up. If it's becoming more flat, it means it's slowing down. Okay. So we have one more graph to look at. This time I'll put you in your groups again. I'm only going to take a couple minutes on this one, but I'm very curious to see what you say. So I just want you to quickly burn this graph into your brain, and then I want you to, within your groups, talk about what if you think the graph is speeding up or slowing down. So quickly burn the graph into your brain, and then discuss. I know I didn't give you guys a lot of time to talk about it, but that's because I think at this point, I think you guys are pretty comfortable with this. All right, so is the object in this graph speeding up or is it slowing down? And in this particular case, it is actually speeding up. So why is it speeding up? Once again, we want to look at the slope of the graph here. Is the slope becoming more? Is it becoming more vertical, or is it becoming more horizontal? Right? Is it, in other words, is it becoming bigger, or is it becoming small, or is it becoming closer to zero? In the very beginning here, our slope is pretty much very close to zero. It's very flat, so which means that which means we're sort of barely moving. Here, our slope is has gotten more steep. Here, it's becoming more steep, and towards the end here, it's getting pretty steep. So our velocity, even though our velocity the whole time is negative because our position is decreasing, the slope is becoming more and more steep, which means that the object is getting faster and faster and faster, even though it's moving in the negative direction. So we got to look at where is the slope going? Is it becoming flatter or is it becoming more vertical? And that gives us an idea of whether or not the object is speeding up or if it's slowing down. So that's pretty much the gist of these acceleration graphs. Does anyone have any questions about some of the nuances of them? All right, so what are we going to do today? We are going to start working on our next assignment here. This next assignment here is just called position and velocity graphs. Nothing particularly special about the naming. So in this graph here, in this assignment here, we're just going to look at some graphs here and we're going to try to come up with some rules or some ideas on what they mean. And so we'll keep working on this today and next period. So the link is, so the assignment is on Canvas here. I also just linked it in the chat here. So that is what we are going to be looking at today. So there are going to be some tables for you to fill out, a couple of graphs to analyze and figure out the position and velocities in. And then you have to draw a couple of graphs. So yeah, we're going to work on this for a few days and let's see how much of this you're able to figure out.